Hey guys, and welcome to another lesson in our course for solar energy. In this lesson we designed, or in the previous lesson we designed our PV system. Now we would like to do the shading analysis, the 3D shading analysis. So we have here two options here for horizon, which is far shading due to far objects like buildings in 5 to 10 kilometers, and we have near shading due to the components or due to the buildings or trees, any building structure close to us. Okay, so when we would like to do shading analysis, we start with near shading like this. Then after clicking on near shading, number 2, click on construction and perspective in order to draw the building and the PV panels. Okay, so we have here east, north, south and west. Okay, so what I would like to do is to draw our building. So if you get back to our drawing here, this is a project that we are talking about, and we have, as you can see, this is the highest part in the building. Okay, I will not draw all of this. What I'm concerned with is this part only. Okay, because this is a higher part and this is the part at which I'm going to install my PV panels. Okay, so I would like to draw this. In order to draw this, I will need these dimensions, the length and width of this building. Okay, and then we will add another one here. Now before we see how to do this, I would like to show you the different options that we have inside our program. So as you can see here, if you would like to create any element, you will say create like this, and you can choose elementary shading object like this. Now this will give you different options. If you have this shape, parallel piped, or for example you go like this, you will find a prism. If you go like this, you can find a house with a two-sided roof like this one, classical one. You will find here one two-sided like this, okay, which can be useful in some constructions like the parking area for cars. You will find here you can add a tree, you can add a wind turbine, you can add anything that you would like. Okay, so there are many options here that can help you to construct what you exactly want or what you would like to do. Okay, this is the first option. After this, you can click on render like this, and you will have your own shape like this. Okay, now if you close like this, you will see that this object, render again, you will see that this object is now added. You can see parallel pipes, you can see it is added now to the program. Okay, and you can add your PV panels and etc. Now let's show you another one. If you click on it like this and delete like this, then go to create, and then you can elementary shading object like this again once more. Let's show you how to control dimensions. Let's say you have a house with a two-sided roof like this one. You can control the height, Z, you can control length, you can control width of this building. You can see X, Y and Z. Okay, the three axes. Now for example, you can see that width dx is 8 meters. This length from 0 to this point, this length is x-axis. You can see here, you can use measure like this, and as you can see here, you can see 8 meters. Okay, this is a distance in x-axis, and this is a distance in y-axis, approximately 12 meters, which you can see here. If you go up here like this, z is approximately like here. Okay, so let's just skip, click like this, and here. Okay, so it's approximately 5 meters like here. Okay, neglect this part, exactly it will be 5 meters. Anyway, you can see here, for example, if you have dx 8 meters, if you would like to change it, you can see here 8 meters. You can control it like this until 0x and increase it again. You can control y, decrease y to 0 and increase y again. You can control the y-axis or the z-axis from here. You can see z is increasing, as you can see here. Okay, you can control like this these outlets of this building, which is called eaves here, gable eaves and lateral eaves. Okay, like this. Okay, so you have many options you can do. Also, as you can see, when I control this, as you can see here, by controlling this part here, you will see I can change tilt angle. So if I have a roof of 30 degrees, I will simply say 30 degrees and enter like this. So this roof is now inclined by 30 degrees from the horizontal. All of this depends on what you see in the location itself. Okay, and you can see here, if you control this, you can control Z. So this one is related to this one, can control Z, yes. However, it controls approximately the tilt angle. Okay, it controls tilt angle. This one control height of the building, as you can see here. So one for X and Y, X and Y. This one related to lateral eaves and gable eaves, and this one is related to tilt angle. This one related to Z, or the height of the building. Okay, that is just for illustration or help you understand. Now, if you would like to move this drawing, you can simply use this hand to move like this. You can use this rotate to rotate and look at the building in different views like this. You can look at XY view like this, two axes, X and Y. You can look at XZ. You can look at ZY as you would like. You can zoom in like this and zoom out as you would like. Okay, so this is how you can control a building like this. Okay, so this function, elementary shading object, to add just one object. Okay, great. No. Okay, so currently we have this. Now let's get back to our drawing and I will tell you why. So we have this building. Okay, let's say this is the roof that we would like to add. We will assume that we are talking about this part only, just this part, and add this above it. Okay, so let's first see how can we do something like this. Number one, I will see the distance here, length and width. Okay, so I will right click like this and measure distance. You can take this point like this here. I would like to measure this length like this till here. I will click like this. It will give you approximately 11.9. If I just make it like this, it will be approximately 12.8. Okay, approximately. Of course, you will measure this in the location itself, but for now we are just measuring it using Google Maps. So let's say 12 meter as a length, and the width itself is approximately 7.4. Okay, so 7.4 and 12. So how can I do this? Get back here to the program here and first create a building. Okay, since we have several elements that will be combined together and form as our building, not just one element but a group of elements. So I will go to building like this, double maximize this, and it will open you the same settings, everything. Then I will click on add object like this, and then I will add this shape. So what are we going to do? We will select a parallel pipe like this, and we can have this square shape. Now we can control the length and width, right? Let's say length equal to 12, if I remember, 12 meter. Okay, and the width is if I remember 7 point, I totally forgot. Okay, so we have here 12 meters and 7 point, let's say 7.4. Okay, and 7.4 like this, and 7.4. Then zoom out like this. So we have this large roof. okay, and then we will control its height. So we have 12 meters and 7.4. Okay, now control height of this building is, let's say we have a villa, and we will understand, or we will know that this villa, for example, is 9 meters in height. Okay, like this. So we'll have this roof at 12 9 meters here. We can reverse it. We can make it this one 12 and make this one, sorry, Control Z to return back, make this one 7.4 and make this one 12. Okay, it doesn't matter, you can rotate it in the end, okay, to make it exactly similar to this this figure, okay, like this. Okay, then we can rotate it like this to look at it in another view like this, okay, like this. Now close this object. Now we have this object. Okay, we can double click on it again once more. We can simply click on this one again. If I would like to modify anything, edit an object from here, and then I will make its color, let's say okay, the same color, and render. This will be our first one. Okay, great. Now I would like to add the second object here. Okay, this object will be let's say 3 meters in height. Okay, and let's see its dimensions. So let's say this height of this part is 3 meters, and let's see its dimensions. Okay, like this part. So I will take it from here to here. Okay, 5.6, okay, and 4.2, 5.6 and 4.2. Okay, 5.6. So we can add another one. 5.6 and 4.2, like this, and its height 3 meters. Okay, like this. Okay, we will make its color. Let's make it a little bit darker like this, and render. Then close the object. Now you will see this is our object. Now you can see it is down here. I would like it to put it up here. What I'm going to do is simply I'm going to rotate like this. Okay, you can first use XY view, for example, not XY. Let's make it XZ. Okay, XZ. Then I'm going to move selection and move it up like this to make it accurately above this building. Okay, like this. And let's look at another view like this, and it will be just click on this one and drag it like this. So if you look at the 3D view, congratulations, you have added the one successfully, or this shape successfully. Now you can see this is larger than this. Let's make sure of this. Okay, this is a length and this is a width. Okay, length and width. Okay, great. Now we would like to add this other object, this one, this small one. It will be from here to here for, let's say, 3.4, just okay, again like this, from here to here, 3.4 and 1.9, 3.4 and 1.9. okay, 3.4 and 1.9. okay, 3.4 0.4 and 1.9. And let's say this height is 2 meters. All of this will be measured inside the site itself. Okay, let's make its color a little darker. Let's say this color, for example. Okay, like this. Okay, now how I can adjust it? Simply go to XY. Okay, it is exactly here. Go to XZ, not XZ. Okay, then you can see here to move up. in the z-axis. If you would like to move in x-axis, you simply click and drag like this. Okay, if you would like to move up, simply you have to go to the axis like this. Click on this one and drag it like this. Okay, now let's look at the other view. XY. Okay, great. Let's make it in 3D and let's look at our object. This object is where exactly? Let's look at here. It is exactly beside it. Okay, beside it. So I will move it like this, drag it like this. Let's look at the other view. Okay, great. Okay, now we have the two objects beside each other. Now I will have to add our panels, right? Okay, so this, all what we did right now is that we have this shape for a building. You can see this is a building consisting of 3 objects similar to this one. Okay, so it is now one block inside the program since we selected building. If I close this one like this, you will see one building. You can see one building together. Okay, you can even, if you click on modify, you will be able to move all of this building together as one block. Okay, that is a benefit of doing the building structure. Okay, now what next? Next, we would like to adjust our building similar to with respect to north, south, west, and east with respect to the reality. What do you mean by this? Okay, so if you look carefully here, this is the north. Okay, the perpendicular line upward representing north, perpendicular line north in negative direction, east and west. Okay, so what I'm going to do is that I would like to rotate this building and form an angle in order to adjust this exactly with north and south. How can I do something like this? If you go to this one, okay, if you go here, this is using Google Chrome, you will find an extension called protractor here, which is used to measure the angle, okay, with respect to another location. You can find this extension inside Google Chrome. If I click on protractor like this, you will have this shape. If you would like to move it like this, okay, like this. Okay, so we have this north here, and I would like to find the angle between south, which is between here. Take this one and drag it here, so we have north, south, right? Now this is the other direction. I would like to make it perpendicular as I can. Of course, this is just an approximation, as I can. So we have this building looking at this direction with a certain angle between it and south, right? So we have south green, and this one is the direction of this building. Now what is the angle between them? You can see here 50.1. If I would like to make sure, if you move this one, you will see angle 0 until here, approximately 50 degrees, okay, perpendicular to it. So we have 50 degrees with respect to south. So that is what I'm going to do. I'm going to the program like this, okay, and I'm going to adjust this to form 50 degrees with south. So you will see that here we have this building. If I choose 50 degrees, azimuth 0, okay, means it's facing south here, okay. This is the direction of this one. Now what I would like is to adjust it like this. Okay, so what I'm going to do, let's say 50 degrees, and see what will happen inside the program. Now you'll see it looked in this direction, right? However, you will see here like this, north. Okay, you will see it is looking in this direction. If you look at here, looking like this. So it means that in this program, if I say -50, it will do exactly what I wanted, like this. So if you look carefully here at this one and this one, you will see they are exactly similar to each other. It forms 50 degrees with south, okay? Azimuth -50. Similar to this building. Okay, great. Now what next? The next step is to add our panels, right? Our PV panels. So I will go to create, and you have different options for PV panels. I will choose rectangular PV plan. And remember, we have 2 parallel strings and 3 in series. We have 6 panels. 6 panels, 6 panels, 3 in series and 2 parallel, right? So we have total of 6 of these panels. Okay, so the first step is that we will go here. You will see tilt angle and azimuth. We will exactly have control in them. If you remember, we have control on them from what we have learned. And if I would like to change their size, remember that these panels will be on one row and other panels will be another row. So I will divide the 2 strings into 2 rows. Okay, one row for a string and another row for a string. So each row has 3 panels, right? 3 panels. So I'm going to choose here 3 panels like this. How many in x-axis and how many in y-axis? Okay, so first you can choose between landscape and portrait. It can be like this and it can be like this. Landscape and portrait, these 2 pi width and pi length. Okay, now how many modules in x-axis? You can see how many in x. 1 2 3 4. How many in y-axis? 1 2, like this. So I will have only 3 panels. Okay, so I will make it 3 in x-axis, like this, 3 in x-axis, and just 1 in y-axis, like this. So you can see 1 2 3. Okay, 1 2 3. If you look at y-axis, we have 1. If you look from here, 1. If you look from here, 1. If you look from here, 3 in x-axis. Okay, like this. So this is the first string. Okay, great. Now what next? We will need to define partition. What does define partition mean? How many rectangular strings? How many strings? How many rectangles in, or how many strings in x-axis and in y-axis? So how many number of rectangle strings? So as you can see, we have 1 string, right? If I look in x-axis, 1 string, and in y, 1 string. So I make this one and make this one 1 2. Okay, like this. Okay, number of rectangles. So all of this is 1 string. Okay. Okay, so what next? Okay, so we did this one, so we have to close like this. And as you can see, we can't even see it. So let's just do XY view like this. Move it in this direction, and then in Z axis like this, move it upward like this. Click here and move up like this, okay, and ZY XY again like this. Okay, let's move it like this and like this. Okay, like this. Okay, and even you can see the shadow of the PV system. Okay, So this will help you to provide space between these two, like this. Let's see it in all view. Okay, like this. You can see we have this PV string floating a little bit. Okay, so let's just make it the same height, modify. Its height 9.11. remember this is the height is 9, so I will just provide 3 centimeter, okay, because the program suggests this, so it will be not just touching the ground, just a little bit higher. Okay, not just above the building exactly, because the program itself gives you tells you that you have to leave 2 to 3 centimeter as a distance between them. Okay, now what next? Go like this. So we have the first panel and with their own shadow. Okay, now the next step is that I'm going to copy this. So I will use select like this, can double click or go to here, then copy or control C and then control V like this, and then you can control it in y-axis like this, okay. So you have to double click here, you will see that we have 3 and this also forms one string. Okay, the same exact settings as this one. Okay, now let's look at it. Okay, great. Okay, what next? We would like to see the effect of shadow of this building first. Okay, so what I'm going to do is to go to shading animation tools and then shading animation like this, and use the step duration 1 minute. You can use between 1 to 15, it doesn't matter at all. 15 will make the simulation faster. And as you can see, day of year, which is the day at which the sun will be very close to the ground, very close to the location itself. If you remember, in the northern hemisphere we said that 21 of December is the closest to Earth. If you are in the southern hemisphere, it will be 21 of June, right? So here we are talking about December. Let's run this animation and see what will happen exactly. Okay, you will see that there are some losses, 2.5% on this day. Now if I would like to return back the animation like this and see why this happening, you can see this panel provide this shadow on this one, right? As you can see here, during this part and at the end of the day. So how you have to do, you have to move this one a little bit farther, right? So if I click on this one, scene object, modify, and then take this one a little bit away like this. Let's see clearly. Okay, let's move it a little bit like this. Okay, now let's see the view. Okay, everything is fine. Now let's see if there any difference will happen. Go to tools once more, you can see 2.5%. let's run once more. So you can see 1.6. let's see this animation slowly. Okay, you can see still a small part due to this chat. Okay, what I can do again is that I can modify this one, select this one and move it a little bit to the right like this and a little bit to forward like this. Okay, and let's see. Okay, this is one is floating. Okay, floating here. So let's move it a little bit to the left. Let's see if it is possible. Yeah, exactly like this. Okay, then I will run this analysis once more. Okay, so let's see what happened exactly. Okay, so there is still some shadow here. Okay, due to what? Due to not these panels but this building. Okay, so I'm going like this. As you can see, it is just a form of trial and error. Okay, so let's see. Okay, a little bit to the forward like this. Okay, let's run once more. So let's see, a very small part due to this one, right? So if I just move it a little bit to this one, okay, move it a little bit forward like this, and move this one a little bit to the left. Let's see if this possible here. Okay, let's see, just small part of this panel. Okay, we can just make this one a bit like this, a little bit like this. Okay, so it is just form of trial and error. Let's see if everything is fine. Okay, this one is out of boundaries. Okay, like this, here, this one. Okay, let's see if it's better or worse. Okay, let's see here, this one is floating again. Okay, so there is another option that I would like to try. Okay, okay, this one, you can see this one. Okay, so how about we can double click like this and make it a portrait, for example, like this, and close. Okay, so we have this in the portrait form. Okay, 3 panels in portrait form. Let's see if this will make any difference in the electrical losses. Yeah, it is much better right now. Okay, as you can see here, very small part. Okay, now since we did this simulation for this 21 of June, 21 of December, we have to do it again for the reverse direction, which is 21 of June. Okay, 21 of June. Then run once more. Now you will see on the other side, okay, you can see on the other side, this building affected all of these panels. So what can I do in this state? You can see this one covering all of this because it is very close to it. All you have to do is you have 2 options. Number 1 is to take these panels and put it here if it is possible. because this one affected the production of electricity. Okay, you can see very high losses during the next day, this day. So if we just take it like this, okay, like this, take down, you can make it in X like this, and move it like this. Like this. Okay, and let's see. So this can be possible too, is to put one here and the other one here. Okay, let's see if this will make any difference for us. Okay, you can see here almost zero electrical losses, as you can see here, very small losses. Okay, like this. Okay, if you would like to save this one, all you have to do is save like this and make it, let's say, for 10 seconds and best quality. Save it on desktop, play the animation, and you will see this is the animation for the shading effect on this location. Okay, so this is in the morning, and then after this, when we, so this is the start and the end. Okay, now what else? You can also, if you would like, if you have a trees, okay, if you have a tree, you can simply add a tree like this, create elementary or shading object, then select tree like this. You can control this diameter of this trunk. You can also change its height. Let's make it 7, for example. You can see it becomes larger. You can control these dimensions of this tree, this height, and etc. You can render like this, and you have a nice tree. You can add this object here, X, Y. Let's move it in this direction like this, and in X-axis. Okay, let's look at XZ. Like this. Okay, and okay, let's look at 3D view. So you can see we have this tree. You have this tree that can cause a shadow on the system, right? Okay, so if I would like to do this, you can say run. And let's see if this tree will affect our PV system. Again, as you can see, zero losses. If I just make it closer like this and closer like this to see how it will affect my design. Okay, like this. Okay, and let's see if it will do anything right now. Okay, nothing again. Okay, why nothing? Because this one is on 6th of June. So let's make it December once more. Like this, 21. And run. Now you will see electrical losses due to this tree. Okay, so what I have to do is to, again, if I have this tree, I will move it like this and see if this will help me at all. Like this, you will see electrical losses becomes smaller. Let's make it a little bit away like this and move it like this and see what will happen? Again, due to this shadow effect, still we have, if I double click like this and make this one, so you can see this is how you can solve this problem of shading effect. That's why this analysis is very helpful in many applications like this. And let's run once more. Okay, great. As you can see here, 0 losses. Now let's get back again to June, like this, 21 of June. You can see again this one affected us. So the other option is to take this one and put it here. So if I just make it like this and move this one like this, this is one option. Okay, but the tree will also affect, so we have two buildings that affect us. The other option is to take this and put it here and to try to leave some space between them, like this. So for example, if we go like this, like this, click here and drag and go down like this and like this. So let's see in 3D view. Okay, like this, take it here, take it like this, take this one back, and let's see the 3D view. Okay, so let's try and see if this will help us to prevent these shading effect. Okay, 0 losses. Now let's go here and see on December 21, run once more. Okay, 1% losses due to this one very small touch at the end. Okay, so this is how you do analysis or the shading effect analysis. Then we will go to table here, recompute, close. But first, according to module strings, we would like to see the simulation shading depending on strings, and we divide them into strings. Then we'll go to OK. So we have done the near shading. Horizon is for far objects, buildings in 5 to 10 kilometers. Now what I'm going to do is simply I'm going to get it from read and import to get the data from weather station. But first, we already know about this curve, the sun curves, sun paths, as you see here, each path representing the movement of sun. For example, this one representing movement of sun on June, this one representing movement of sun during December, right? Then we will say read and import, and you can select any database you would like, let's say Metronorm or BVGS, BVGIS, import. Okay, so it obtained all the data for the horizon. Okay, then we are going to save once more like this and then run the simulation and report like this. Now this will show you all the details that we discussed before, like this. Okay, however, there is an additional part due to shading analysis. You can see our building, PV panels, the tree, and you can see these are the losses. As you can see here, these are different types of losses during different parts due to this panels. Okay, these panels affect this panel, affect this row. Okay, like this. So this is how you do the shading analysis in PVSyst. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You will find also in this academy, you will find the different feedbacks from some of our students that joined our courses. You can, for example, join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits. You will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics. Okay, and you will find that inside, when you join this membership, you will find this blueprint that will guide you in which classes you will start with when you join this membership. So thank you, and see you in our membership on Khadija Academy.